Hello and welcome to Diana's Makerspace. On this Makerspace, I'd like to show you what the KZ80 computer looks like fully assembled. The flash memory has been programmed, and it's ready for test soon. Let me just switch over. Now with the KZ80 computer, you can see I did a few things here. What I did is I added a switch here so that when you turn the power, you can turn the 4 megahertz clock on and off, and also it's space for a switchable clock. That's why I have a two-stage switch here. So basically, you can put the other stage over here. And then this is the I/O port. This is the I/O port status. It tells the data that's on the I/O port. This is the data port status, the reset switch, and if we look closer, you can see the address port status for the lower 8 bits of the address space, so you can see what's going on. Now, what I did when I made this is you can see there are various jumper wires I used to go around. So what I did was I followed an idea from PCB manufacturing, and what that is basically you just take it and you wrap the bus wires along like this. And I used tape and other things to hold it in place. And I made it so that the memory could easily be taken out without having to use a chip bed. And then you can see basically on the latch register for the I/O bus. That's register for I/O bus. The NAND gate that's used to trigger the latch register. One thing I was planning to do is I was going to do also another one with a transistor, because if you use a transistor, you can also use the transistor as an inverter, which will save board space. Well, pretty soon I'm going to get ready to do a test on this. So when it does the test, what will happen, the I/O register will show like a barber pole pen. On, off, on, off, on, off, on, off, on, off. Now, to do this, I used to use jumper cables, but I went back to using DuPont wire because I had too much issues with jumper wires breaking. So now I use DuPont wire. Now, the yellow wire is the clock wire, and the green wire is the reset wire. So I made these so you can attach this any way you can. And what my goal here is to try to make a Z80 computer with a minimal amount of chips to demonstrate. And the other thing is I found out basically by using an 8255 in the next model, you could actually have a very easy parallel port control, because what you do, you use the I/O control latch to the chip select, and then you just use A0, A1 for the register select, and you can use the I/O port for 3-port I/O control without having to use a multiplexer. And I've expanded this design to 65816, 65816, 68,000 P8. So what I did is a combination Z80, 68,000 P8, Z80, 65816, and Z80, basically another one. But on one of them, I also have an 8951, so making a tri-processor, where one processor is the master processor, and the other two are the client processor, so a server processor and a client processor. And the idea is basically I wanted to see what it would take. So the Z80 68,000 is like sort of what I consider my mini Osborne 1. This one is basically sort of what I'm considering part of a gamer system. And I do think retro chips, and even using retro chips for AI, has a lot of potential, because basically everyone talks of cores, but if you have a lot of cores on a chip and the chip locks up, all your cores are locked up. So basically, by having separate processors with separate memory, and then later linking shared memory to it, a section of shared memory, you increase the reliability, and also you increase the thing about lockups or standing waits. Well, let me know what you think. The best way to reach me is on YouTube, Facebook, Pinterest, X, and this has been Diana's Makerspace for April 14th, 2025.